Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things substrates, Polkadot, and Web3. Today on Relay Chain, we have Christine Perry from SKALE Network. Welcome, Christine. Can you introduce yourself?
Yeah, absolutely. Thanks for having me, Joe. And as you mentioned, my name is Christine Perry, and I lead solution engineering at SKALE Labs. So what that basically means is I maintain the customer journey throughout the pre and post implementation. So when developers are building a Dapp and they're deciding whether or not they want to use a scalability solution, we kind of talk to them about their needs for that and then help them build partnerships and integrations throughout their integration with us. So that's what I do at SKALE Labs.
Okay, great. So we're going to get into a little bit of those teams, but as a general overview, what is SKALE Network?
Yeah. So great question. SKALE Network is a decentralized proof of stake network that's meant to be layer 2. And the idea is that we don't want to be a Ethereum killer. Instead, we want to augment it by helping it by speeding up transactions that don't necessarily belong on Ethereum. And so you can think of it as sort of just like AWS for blockchain, where instead of having one blockchain to be able to process transactions, you can use an elastic sidechain to be able to run transactions that need to run faster, or manage tokens, be able to save costs. And we can get into more of that later if we want to do a deeper dive into those concepts too.
Yeah, sure. But starting from a higher level, you've talked to a lot of teams who are building applications on blockchains, and what were some of the problems that they ran into or difficulties?
So there are two major problems that app developers come to us with. The first one is going to be transaction speed, and the second one is going to be transaction costs. File storage and managing tokens comes secondary, but to tackle the first two, that was sort of the first mission that SKALE Labs decided to kind of take on to solve for Ethereum. And when Dapp developers have these issues, they've already reached the friction point of, I want to be able to use Ethereum, however, I can't seem to make it work like a traditional Web 2.0 application today. Instead, you feel a lot of friction for the end users. And what they're trying to solve for there is being able to run their transactions faster and also decreasing the cost. On a layer 2 elastic sidechain, we actually remove the idea of cost. And so for the end users, they don't see a cost, but for the Dapp developer, it's paid for upfront by sort of like a subscription model. So you decide whether or not you want a small chain, medium chain, or large chain, and you only pay for what you need at that specific time.
And then that you're paying on Ethereum.
So you're paying on Ethereum. That's correct. So you can think of SKALE as being a Dapp kind of attached to Ethereum. And so in that essence, yes, you're able to stake on Ethereum with the SKALE token that spins up your SKALE chain. And once you stake for that SKALE chain for, let's say, 6 months or 1 year, you're then able to process your transactions in that environment in a faster way and also decrease the costs. So by that, I mean, what's really useful for Dapp developers is that they don't have to learn any new languages. Instead, SKALE is supposed to be extremely compatible with Ethereum. So the same transactions, the way you can run them on Ethereum, you can run them on SKALE as well.
So are you exposing the same kind of interface of a smart contract environment, and that will eventually make its way to the Ethereum chain?
In a way. So what we do is we forked the Analyst C++ version of the Ethereum EVM. And by doing that, we've enabled developers to be able to run their smart contracts written in Solidity directly on SKALE. So when you reach that friction point of, hey, transactions are slow, or hey, the cost is super high, you can automatically just get an endpoint with SKALE and deploy your smart contracts as is directly to SKALE. So in that way, it's exactly like running transactions on Ethereum. Now, when we're managing tokens, that's where we don't actually transfer any tokens out of Ethereum. We kind of use Ethereum like a bank. So the tokens stay there and sort of like a deposit box, and you're able to work with clones in the SKALE chain side to speed things up, which has a direct mapping to what's going on in Ethereum as well.
Yeah, so you're kind of creating this side environments where people can execute without any kind of costs. And then how do you take care of the speed thing? I mean, the cost is getting settled later, right?
Yeah. So taking care of the speed thing, the way that we were able to do that is We took a look at so many different consensus methodologies that were out there and decided to kind of create our own. So our proof of stake consensus protocol works in sub-second time. Now, a lot of what goes into it is basically because we decided to run the consensus in this asynchronous way. So every time a transaction is received, you can think of it as like multi-threading, to where we're not going to delay the transaction of one before receiving the other. Now, in doing that, we are able to speed the transactions up. What happens there, though, is to really speed it up, it comes down to the validation part, where we're using BLS signatures to quickly be able to sign a transaction across the different nodes within a network before it's finalized on the blockchain. And again, that happens in less than a second, and you can process about 2,000 transactions per second currently with a large chain.
Okay, I do want to talk about like the consensus stuff a little bit more later, but like before we get to that, I'm just wondering, like, what were the problems that led you to decide that like layer 2 was the solution to a lot of these issues, and like that trying to change layer 1 or implement it in some other way wasn't the solution?
Yeah. So if I could tell a story, I came to the blockchain space because I initially wanted to set out to build my own Dapp. I love travel, and I want to combine travel application with the blockchain. And just like other developers that are already in the space, I quickly came across the issue of it's really slow and it costs a lot to run anything.
Yeah, so you were the first user almost, or the first person who needed it.
Yeah. So for me, I was the first person that kind of needed to understand that maybe instead of building a Dapp, it was time to actually figure out how to join the cause of building infrastructure to help the blockchain environment. And that's when I got introduced to Jack O'Halloran, the CEO of SKALE Labs, who explained to me the need for being able to empower developers and enable them to build dApps that are run faster and don't incur that quite as much of a cost.
Yeah, and did you try to make this travel app on Ethereum?
I did. So it was the first app I made through the Consensus Academy program for developers. I took that course, built a small Dapp, quickly ran into the problems, and almost walked away and went back to just marketing tech and SaaS. But after talking to Jack, I decided to, abandon the Dapp for now, and then continue along the lines of helping out infrastructure.
Yeah. So were you working in like a different software company before this?
Yeah. So my background, to take it further back, I used to build software for the Department of Defense, and it was full stack development. And then I quickly transferred over to more customer facing roles. Think product innovation, solution engineering, solution architecture. And that led me into the market tech space for about 8 years. There, I worked for companies being at Oracle, Optimizely, Mixpanel, to name a few. And that's where, I felt I kind of got stuck, and the type of tech wasn't necessarily changing, and we were more building tech to just make more rich companies richer.
Yes. I've been there as well. Yeah. So like, how do you think that like layer 2 stuff or layer 2 solutions can play a role in helping like applications or blockchains operate with each other?
So I think layer 2 plays a role in that it acts as a really nice bridge that sits on top of the layer 1 solutions. There are quite a few layer 1 solutions out there already, but the one that seems to be gaining the most traction with developers is Ethereum. And due to that, layer 2s that integrate with Ethereum from the beginning are going to be able to help Dapp developers that are facing the challenges that they're seeing today. Again, talking about the speed and the cost. Now, when you think about Ethereum, because every Dapp is deploying to Ethereum, as you can imagine, it creates higher costs. It also creates lower times. And so because of that, there's stuff that is being put on Ethereum that could be offloaded onto a layer 2. So again, in the spirit of not wanting to be an Ethereum killer, we still want developers to be able to deploy, let's say, ERC20 tokens, ERC721 tokens directly to Ethereum, because you can think of it as like the bank. But for transactions that maybe are more social in nature, or the game logic within a game, that's something that can be automatically taken over by a layer 2 solution. There are tons of layer 2 solutions out there where you would be able to implement them, run them alongside of Ethereum to be able to speed up your game in that way. The benefit of this is that with layer 2, because Web3 has made it so easy to be able to connect to these blockchains, you can think of it as just having multiple resources to get the job done. So one Web3 connector goes to Ethereum, Ethereum, the mainnet, where you're able to maintain the parts of your application that need to be there. And the other Web3 connector can go to that layer 2 solution, such as SKALE, for running transactions that you need to run a lot faster, at least to make your application appear more like a Web 2.0 application today.
Yeah. And so like, as you mentioned gaming a couple of times, but what do you think are some of the best verticals for blockchain in general?
So it really surprised me. When I initially started the initiative of working at SKALE, I thought that the main use cases would be in DeFi or gaming, and I was wrong. So yes, about 50% of the applications that I talk to today fall within those buckets, but I find that I end up talking to verticals, Dapps are building within verticals such as real estate, agriculture, social impact, marketing tech as well, trying to create Salesforce on the blockchain or create A/B testing on the blockchain. There's a lot of different companies out there that are trying to disrupt their respective spaces. And I find it really encouraging for others looking to get into the space but don't quite know how. Pick an idea and run with it.
Yes, like what was the thing that changed your mind on that?
The one that changed my mind on which part?
On like that gaming and DeFi would not actually be the main use cases.
Actually talking to them. So at SKALE Labs, as solutions engineering, my role is to be able to go out, meet the developers that are building in so many different verticals and understand their problems. So think of it more as just like data gathering. But as I'm data gathering, we're trying to figure out whether or not there is a way that a layer 2 solution can help their specific vertical. And so throughout this effort, what we've been able to do is aggregate just quite a few dApps that go beyond gaming and DeFi. And that's what changed my mind about that. It's not just gaming and DeFi out there that's looking to build on blockchain and also scale on blockchain too. So
yeah, I'm interested in the use case question just because at Parity, we're so focused on abstraction and like really low level stuff that like the end use cases is like really far away from the work that we do because it's more in like networking and stuff. And so I'm always like interested in like what applications that you see being developed and maybe like the surprising ones, like not the obvious like DeFi type stuff.
Absolutely. So some of the surprising ones, well, before that, I want to start with, the approach that we're taking as well, because as you mentioned, we are building heavy infrastructure, so it is more like on a network layer. But when the person that's going to use it, it's an end user. And so we need to take them into consideration and then work our way backwards. And so with the end user for someone, let's say that they're looking for using a music app that's like SoundCloud on blockchain. Essentially, the end user just wants to be able to play their music in a fast way. They don't want to be necessarily hindered by having to think about the fact that it's running on blockchain. Instead, that should be something that's kind of like hitting in the background. Like you don't go to Facebook or Amazon today and say, I wonder what their infrastructure is. Are they on blockchain?
Right.
You just use the app. And so that's where we're kind of seeing the direction of Dapps wanting to take their applications to. Wanting to start with the end user, making sure that it's easy enough for them, and then building up from there. So some of the interesting use cases that I ended up coming across were, to pick on the one that I just mentioned, is Audius. Audius, they are building like a SoundCloud for blockchain, where essentially you're able to play music from a provider or an artist that you love, and you're able to donate or be able to pay them directly, instead of having the other way around where you're paying a service that's just playing their music, like Spotify or Pandora today.
Or a record label. Like 20 years ago.
Exactly. So that's a really interesting use case. Sports betting is also one that's really interesting, one out there, because sports betting is something where it just makes sense to be on blockchain. That's a DeFi application. Another application that I recently heard of was in agriculture. There's a Dapp developer that is blending together satellite imagery and blockchain to be able to bring insurance to small town farmers. The pilot, if I remember correctly, was kickstarted in Niger, and apparently it was already successful. She was part of one of the consensus innovator programs, and it seems like it's one of those projects that's really taking off.
I think I've heard of this one actually, but yeah, I used to work like on satellites, so I always kind of have like I'm always looking around for like blockchain and satellites type stories. It's really interesting, and it also kind of goes to like the Oracle problem of like how do we deal with some of this data, like in insurance and imagery. That's like a perfect case of how do you determine what's a good image.
Right. Do you want more use cases?
Go ahead. I'm not going to stop you.
Other use cases that I heard of, there's an app out there called Volo, which is really exciting too. It's one of those applications where think of marketing, where you go and you buy, let's say, a coat, because we're in Denver, on a website. Typically, you'll search for a coupon code, you enter it in, you get your discount, that's it. What this application is doing is using the power of blockchain and a very common, model within marketing tech, which is sort of like a referral code. You get a referral code, and if you use that or give it to someone, they get that 50% discount, but you and them both get paid off from that discount instead of just going straight to both of the companies that's having that discount run, which is a really interesting use case because it's already tying into something that's really common in marketing tech, but putting it on blockchain.
Yeah, so let's go from like high level down to low level now and back to consensus. I want to ask you about that. And it's interesting to me that like as a layer 2 network, you have a consensus algorithm at all and like validators, because normally we think of like, well, if you're layer 2, then the actual like finalization belongs to layer 1. Yeah. So what are you doing with consensus?
Yeah, absolutely. So to start high level and drill down, SKALE Network is a proof of stake blockchain. So essentially, proof of stake means that each node within a network is going to have to stake a certain amount to be able to validate on your specific SKALE chain. Now, what we do is we group together 16 of, let's say, 1,000 nodes that will run a SKALE chain. Each SKALE chain is independent. So each Dapp, they're not going to share a SKALE chain. They're going to get their own one. Ever so frequently, we're going to be swapping out one of those 16 nodes to prevent collusion. Now, the consensus protocol that happens is with each 16 nodes, it works based off of BFT, Byzantine fault tolerance.
So just a quick question, does each SKALE chain need to recruit its own validators, or are there just like generic SKALE validators who can kind of like arbitrarily jump around from chain to chain without any kind of configuration setting?
Great question. So they don't get to choose who their validators are going to be, and we don't choose it either. It's randomized.
Okay, and so the validators don't choose the chain that they're validating either.
Exactly. We also put in other safety measures to prevent collusion or making it a game theory, where you're able to guess which Dapp you're going to serve based off of which Dapp just joined, and you're just joining as a new validator. We leave each validator at less than 80% capacity, meaning they can accept another Dapp to run on it. So the way that we break up our SKALE chains is that each node can run up to 128 small chains. And we do that because we want to make sure that Dapp developers don't feel as if they're paying for more than they actually need. If you're just building your application, you might not need 2,000 transactions per second, you'll just need 20. But that 20 transactions per second is not shared with any other Dapp, it's just shared with yours. Right. So it's actually quite a lot. But for the selection process, that actually originates from our SKALE manager, which is deployed as a smart contract to Ethereum. So from the SKALE manager, we're using randomization to determine which group of 16 validators is going to be selected for the SKALE chain at that specific moment. And then we start the randomization and rotation process for that node, for that SKALE chain.
Like how often does that take place?
So that is configurable. At launch, we are planning on doing that maybe once a month or once every other week, but it's going to be configurable depending on the needs of the specific SKALE chain.
Yeah, so. And then like when you started designing this consensus mechanism, how did you arrive at this model? Like what other options did you consider?
Good question. So I will say that, Stan Kladko, he spent a lot of time just evaluating all of the different algorithms and math out there. And one of the things he was really adamant about was not creating new math, but using something that's existing and has been proven already. And what he arrived at was using BLS signatures and rollups to be able to create our consensus to run in a very fast way. Now, by that, I mean, when you get to the part where each node is signing a transaction to be able to add that block to the blockchain or the sidechain, essentially what they're doing is they're passing around their signatures that's being aggregated and creating a new supermajority signature that's able to be validated at the very end. So all of that, we have a lot of great writing on it on Medium if you want to read up more about how we're using BLS signatures or rollups.
Yeah, so you need to aggregate like 11 of these 16 in order to have consensus on some block. And then, so you're providing some sort of like finalization guarantee on layer 2, and then this will eventually settle on Ethereum, like on the main chain?
So it doesn't actually settle on the main chain. This settles on the individual scale chain. So the scale chain is going to have its own set of blocks that's being created alongside Ethereum. Now, where it will settle on the main chain is if you're managing a token, because a token, one of the things I mentioned earlier is that we don't actually move the token off of Ethereum. It stays there. Instead, we're working with clones. So when you are finally exiting on that token and needs to go back to the main user, we burn it on the scale chain side and the token is released on Ethereum. So at that part, we are actually saving the state of what just happened back to Ethereum.
Okay. Yeah. And then like looking a bit longer term, like I know you're launching on Ethereum soon. It says in your white paper that you're protocol agnostic. Yeah. And like how do you envision like Scale growing into working on multiple networks?
Good question. So I'd say right now, one of the things that we're really working on is a lot of partnerships with blockchain companies that are not just layer one. So API-based wallets is a direct need for Dapp developers, because when you think about the nature of a sidechain, it is meant to kind of be hidden and not necessarily interacted with other than the Dapp developer kind of coding it in. And so API-based wallets allow us to accomplish this because it gives the Dapp developers the tools to be able to switch networks in the backend to automatically go from Ethereum to Scale and back again without the user even noticing. So a lot of, our trajectory around partnerships is building as many partnerships as we can with companies that are also looking to help empower the Ethereum space, so that way we can empower Dapp developers together. Now, because we built our system in a modular way, the idea is that yes, eventually developers, they may decide they want to move from Ethereum to another layer one solution and back again. And being a layer two solution where you are kind of that bridge, it does make it possible to be able to do that in the future. So everything was built in a modular way to where we can swap out everything. You can swap out the EVM. You can potentially swap out the consensus protocol that's being used. You can decide whether or not using BLS signatures. You can swap out Ethereum. All of that in the future, we will be able to swap out and be able to empower developers to go wherever they like.
Yeah. And do you see that as being like one Scale network that's like operating on top of, Ethereum and other protocols? Or do you see that like each protocol would have its own Scale network?
I'd say one. I'd say one.
That would be awesome.
That would be really great.
Just to like kind of wrap up, like you guys are launching soon. What does 2020 look like for you guys? 2020
looks like amazing, beautiful chaos. One, because as many in the space have seen many network launch before, we're about to go through that journey really, really soon. So part of that journey means that we want to make sure that the Dapp developers we're currently working with today are able to use the mainnet from day one. Beyond there, we also want to make sure that we're constantly innovating within Scale Labs and for the Scale network. And to do that, we already kind of have the roadmap of other features we want to add in. One of the top ones is machine learning. Machine learning is another one of those products where it's really hard to be able to run something as computational heavy as machine learning on Ethereum.
Yeah, I want to know now, like, how are you doing machine learning on blockchain?
Yeah, so it started as an interesting, fun side project for Scale Labs.
As most things do.
As most things do. And so with machine learning, we enabled Dapp developers to be able to deploy or upload trained models to be able to do things like price prediction, filter images, or maybe do word filtering directly on their blockchain, on their Scale chain. And with that, what it means is that everything is saved directly to their Scale chain. Their trained model is saved there. And out of that came file storage, which means that you can also save any file there. You can save HTML, you can save JavaScript, you can save any images. Essentially, you can make your entire application decentralized by just uploading your web app to Scale.
I'm interested to see machine learning on blockchain.
It's been fun to play with. I will say that right now, V1 is you upload your trained model, and then you're able to run your predictions from there. So let's say that you upload a trained model to be able to filter out a cat or a dog. You'd be able to upload that trained model, interact with it directly using this, the Scale chain. And from there, you're able to filter out the things that you want or do not want saved directly to your Scale chain. So in a way, it's a way of you being able to add a little bit of filtering to the content that's stored on your blockchain, so that way it doesn't get bogged down.
Yeah, well, I think I did the end out of order because we talked about the very far future of like multiple networks, and then we went back to 2020.
Yeah, no worries.
But like, where should people go to follow SKALE? Or yourself, if you want to show yourself.
Yeah, absolutely. So if you're looking to follow SKALE, you can visit our website at skale.network. And if you're looking to follow us on Twitter, look for us at SKALE Network. And if you're looking to follow me, it's Christine RPM.
All right, great. Thank you, Christine.
Yeah, thank you, Joe.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter at RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io/newsletter.